So, hey there, it's working, right? Good morning, I'm Anashuman Singh, and I'm a GSOC mentee of FOSSASIA last year. And yeah, let's start with the session. The session is about adding a wireless ESP connectivity to the PSLab. And yeah, perfect. So yeah, let's go. I guess everyone knows about the PSLab project, right? What we aim to do with the PSLab project. The PSLab project is basically we aim to integrate lots of instruments, measurement instruments such as oscilloscope, multimeter, logic analyzer into one board, right? A single board, which can be used by students, researchers, and schools, universities for their projects. So with this project, we aim to make the whole board wireless. So the current configuration of the PSLab, we use a USB cable to connect the PSLab to the laptop or to the mobile phone. This project aims to sort of make the whole thing wireless. So let's move forward. Yeah, this will be the abstract of the session. What he'll be covering in the session, there'll be 3 points. The first thing would be connecting the PSLab wirelessly to the phone and to the PSLab Python. The next would be how would we flash the appropriate firmware to the ESP1 chips and the PSLab board. And then finally, we'll have a small demonstration on how we connect the PSLab board to the clients, right? The PSLab Python and the PSLab Android app. So yeah, let's move a bit forward. Okay, so the first and foremost thing which we'll have to cover, what was the need for wireless connections? If the USB connection was working fine, then why did we even need to switch to wireless? So that's the main thing, right? The only way the PSLab board can communicate with the mobile app or the desktop app or anything else which we support, any platform, is using the USB cable. We want to like expand the platforms with which we can work in the PSLab, right? So we want to put the app on iOS as well. Then we want to have a Linux. Then we want to have a desktop app. And the main aim is to like sort of have a single code base for all the development like platforms which we support, right? So for this, let's take an example, right? iOS doesn't allow communication over USB. Like if you want to sort of build something which connects to an iOS device using a USB, you have to do the entire process with Apple, right? Another thing is that there are growing restrictions on communication over USB. So as we progress, the restrictions on what you can send through USB are going to be imposed, and it would be difficult to communicate with the PSLab through USB in the future. So that's why we were exploring on how we can make this communication sort of viable on different platforms and even better. So 2 options for wireless are obviously Wi-Fi and Bluetooth. And let's see how we proceeded. So yeah, what work has been done till now? We chose, so the PSLab V5 had a sort of module, had a sort of a header for a Bluetooth module, but in the V6 we replaced that with an ESP header. So Wi-Fi was chosen as a way to go forward because of some obvious reasons, right? So we can have a much larger throughput with Wi-Fi than we can even have with USB. And then obviously stable connections, right? So with Wi-Fi, we have many ways on which we can do that. We can sort of connect to an access point. We can have it in the Wi-Fi AP mode, and etc., right? So Wi-Fi was chosen as the way forward. And so for that, we would need an ESP chip. And for our case, we started with an ESP01 board and the ESP01 chip. And then we added support for wireless communication in both the sort of client apps which we support, PSLab Python and PSLab Android, right? So let's move a bit forward. Yeah, so this is the architecture which we chose currently, right? How does the PSLab communicate with the phone or the desktop app using Wi-Fi? So we plug in the ESP chip on the PSLab. The ESP chip works in the Wi-Fi access point mode, which means it has the ESP1 chip always has a single sort of IP address. It's 192.168.4.1, which we can connect. And then the client library just connects to the access point, right? So this is the current architecture of Wi-Fi communications. And yeah, so after this, we would be moving forward on how we can sort of set up this communication, which includes flashing the appropriate firmware to the ESP01 chip, then flashing the appropriate firmware to the PSLab board, and then connecting with the PSLab board over the internet. So I'd like to invite Mr. Bessman to do the demonstrations, right?
Yes, thank you. So just setting things up here a little bit. Give me 1 second. I'm just going to connect this. Okay, so like I just cover how to do this, and then I will try to give a live demonstration of how to flash the firmware to the ESP. But basically, what you're going to need is Python and a package called ESP tool. The firmware for the ESP, which we want to flash, is available from that repository under the releases. I'm going to show you just how to download that in just a bit. But the steps to flashing the firmware to the ESP01 is to connect it to a serial bus. So I haven't elaborated on like how to do that because there are just too many options there. For the demonstration, I will be using a Raspberry Pi, but there are infinite numbers of devices with serial buses that you could use. Once you have connected the ESP to the serial bus, you need to get it into bootloader in order to flash the firmware. Like you may be recognizing this from the previous workshop. Like that's just how these things are done. To get the ESP1 into bootloader, you need to you need to connect the GPIO1 pin, GPIO0 pin to ground while holding that low. So while that is connected to ground, you need to also touch the reset pin to ground. If that worked, it should be in bootloader mode. So that the best way to really know whether you did that right is to just, if it worked, you should see that the ESP1 has like it's typically a blue LED, which normally shows activity on the serial bus. That LED should flash briefly. If it does, then you probably managed to enter bootloader mode. But this also kind of depends on exactly what model of the ESP01 you have. There are many different models of the ESP01, which are all slightly different. So that might depend on which ESP01 you have. Yeah, so here is just a screenshot of what it looks like to flash the firmware. Yeah, so the interesting part here is, I guess, the top line. Like I said, I will try to show this live, but in case that doesn't work, this is what it looks like. You call the ESP tool while the chip is in bootloader. You hand it to the ESP01 firmware.bin file, and it will flash it. Once the flashing is complete, you need to reset the ESP01, and if the flashing worked, it should start broadcasting an SSID called PSLab. I think that's that, right? Yeah. So then, yeah. So the PSLab itself also needs a specific firmware for this to work. Normally, the PSLab communicates over over the USB port. But when using Wi-Fi mode, it uses an alternative bus for communication, and that is why it requires another firmware. That's available from that repository. So if you were here for the previous session, we covered how to flash firmware, and it's basically the exact same thing. All right, so I'm gonna try to show this live. So I'm gonna borrow the screen here. Let's see if we can do it live. Okay. So what we're looking at right now, like I said, I'm using a Raspberry Pi for this. Right now I have SSH'd into my Raspberry Pi, which is connected to the ESP01. Let's see if we can flash the firmware, which is this So this is just, like I said, this is the release firmware, which I have previously downloaded from the FOSSASIA GitHub. Let's keep our fingers crossed and see if this worked. If this works. Let's see, where are we? ESP, where are you? There you are. So I think right now this chip is not in bootloader mode, so we can just try and see what that looks like. This is probably not going to work. Exactly, so this is what it says here. So if it's not in bootloader mode, the ESP tool can't detect the chip, so it's just gonna say, yeah, failed to detect. That's expected. So now I'm gonna try to get it into bootloader mode. Like, this is really, yeah, it's such a small thing here, so you can't really see. But what I'm gonna do now is I'm gonna take like a piece of just jumper wire, or yeah, these tweezers actually are excellent, tweezers. And I'm going to touch the GPIO 0 pin. Let me see, which is that one again? That is, yeah, right. It's. Thank you. So if I'm, thank you. So let's see, GPIO 1. That's this one. So this two. Yeah, I mean, if you want to come up here and look for a closer look, feel free. Okay, now it's not doing it. This is very annoying. Why not? Yeah, maybe. So like, I'm looking for this. Like I mentioned, right? So I'm looking for like a blue flash here, and it's not doing it right now. We had some trouble with this earlier. This again for some reason. This is really, yeah, this is not very user friendly. Obviously, I don't know why this is not. It's not cooperating this today. Like, we've done this many times in the past, and then it's never been this big of a problem before. Let me try with that jumper wire instead of the tweezers. Let me just double check all these connections. This is. Yep. Thank you. Like, this was working just earlier, and now it's not. No, it should be those two. Yeah, I probably connected something incorrectly.
So the ideal thing is that when you connect these both, right, so the GPIO pin is already grounded, and when you sort of short these two, blue LED will flash. When the blue LED flashes, it means that it has gone into bootloader mode.
Yeah. So incredibly frustrating. Yeah. Okay. So now I'd switched the. Thank you. So I had switched the UART RX and TX pins. That's why it wasn't working. Now it should be in bootloader mode. Let's try it again. Okay, that looks better. So here we go. It's flashing. All right. So if that worked, it should now start broadcasting an SSID called PSLab. So I'm going to just reset this. 1 second, resetting it. All right. So it takes a while for really the network manager to find it, but it should appear here any moment. So obviously, you know, this whole process could be improved, like user friendliness wise. Very finicky to flash the firmware, but yeah, once you do it, you really only need to do it once. Let's see here. Oh wait, I still have to. Sorry, I need to unground the GPIO 1 pin. exactly. So that's that one, and then. Yep. All right, let's see. Okay, there it is. PSLab success. That's the process to flash the ESP01 firmware to the ESP01. So the next step is to flash this special firmware to the PSLab itself. So I'm going to demonstrate how to do that as well. All right, let's see. I can actually just demonstrate the sort of the whole process, how to build it as well. Okay, I have to just remind myself how to. So the way we do this. Oh wait, we don't do it like this yet. So the way it works right now is we have a special branch for the ESP01. So let's build that branch. And then we're going to flash it to the PSLab. So of course, now I'm building the firmware, but it's also available, like I mentioned, from PSLab. Come again? Yeah, exactly. The GitHub release page. GitHub release page. So okay, I can't see that anyway. Just keeping an eye on the time here, so we have 15 more minutes, 17 more minutes. So once we have flashed this to the PSLab, I will briefly demonstrate just connecting to the PSLab, and then we will move on to the Android part. All right, so let's see.
So if you guys don't know about what we're using to flash the firmware, it's a command line tool called mcbootflash, which has been written by Mr. Bessman himself. It's a command line tool to flash firmware to microchip devices, right? So we are using that, and it's open source. So yeah, that's how it works. And it uses a special baud rate, which is 4600800, which is the baud rate for the bootloader, right? And yeah, it's done.
So that's the flashing process. We have now flashed the PSLab with the special firmware required to enable the Wi-Fi mode. We have flashed the ESP01. Now we should be able to do some wireless measurements. Okay, so like for this to maybe work better, I'm going to connect this to something else so that it's not connected to my computer. Otherwise, I could be cheating. Let's just power that on from any source, and then I will connect to it over Wi-Fi from my computer. All right, so now we just have to wait for the Wi-Fi to start broadcasting here. Might take a few seconds. There it is. Okay, I'm gonna connect to that. And once we've connected to that, the rest just sort of works. It's really completely transparent. So the PSLab Python library will auto-detect that it's connected to a PSLab over Wi-Fi. So you don't need to change anything from how you're normally connecting to it over serial. It's exactly the same process. You just run this command and it will auto-detect. So now we can see, yep, PSL. We can take a look at what the device is. The device sort of handler is a Wi-Fi handler connected on this IP address on that port, and everything works exactly the same as it does if you're connected over serial. It's just a little bit slower at the moment. We're gonna work on improving that.
Here we're going to basically demonstrate some basic measurements using the device. So yeah, we'll be demonstrating analog measurements using the sine wave generator of the PSLab and the oscilloscope of the PSLab. So there we generate a waveform, and then we use the oscilloscope to capture the samples. And yeah, there you go. Let's try plotting it. And yeah, there we go. So this is the wave generated through the PSLab, captured by the PSLab oscilloscope, completely over Wi-Fi.
Now we're going to move on to the Android part of the demonstration. So let's move this over here again.
So yeah, now we'll try to do the same thing which we did using PSLab Python using the phone, right? So in the Android phone, we try to keep this process as simple as possible. It's as easy as 1, 2, 3 clicking buttons. So yeah, you have the dashboard, you open the navigation drawer, you go to the connect device screen. There are 2 buttons. The Bluetooth one doesn't work as of yet because we haven't implemented that. There's a Wi-Fi button. You click on the Wi-Fi button, and yeah, if it shows the screen, this means that the device is connected successfully. All this provided that you have connected to the access point, which is deployed by the ESP before. So let's try that. Just reset that. Sure. So in order to do this, you have to ensure that your mobile data and your Bluetooth, everything has been turned off because they may interfere on some device models, right? So let's do that. Let's just sort of turn off Bluetooth, turn off mobile data. Yeah. And now we'll wait for, yeah. So as you can see, the PSLab SSID is being broadcasted. We connect to that over there. Yeah, it's connected. And then we follow the exact same steps, right? So I'll show them once again. You have the dashboard, you go to the navigation drawer, you go to the connect device screen, you tap the Wi-Fi button. It's not connected to stuff. It's not connected. Is it not connected?
It is connected to the PSLab, yes.
Can you just turn off without and turn on once again?
Should be fine, I don't know.
Yeah, we'll just reset the PSLab once. Yeah.
PSLab connecting.
So you're just connecting. Yeah.
I'm not sure why it's not connected to the.
Mm-hmm. Oh, yeah, computers maybe. But previously it was, I guess.
Previously it was, yeah.
Yeah, that's just true.
Right now my phone doesn't want to connect to it. Now I can't even see it. 10 minutes. Yeah.
Perfect.
Why can't I see the PSLab?
Okay, sure, no issues. Let's try this on another phone which has not been there.
Now connected.
Oh, no, it's connected.
Now
Let's try. Try
Okay.
connecting. Just do the app once. Oh, yeah. No. We open the PSLab once again. And you follow the same steps. We have the PSLab Wi-Fi connected. And then we sort of go to the dashboard, connect device, tap on Wi-Fi, and there it shows connect device, device connected successfully, right? So now what you can do is, you can sort of, we have the sign 1 pin connected to the channel 1. We can go to the wave generator. We can generate a wave of frequency, let's say about 2000 hertz, yeah? And then let's try measuring it using an oscilloscope. And yeah, there you go. Wireless oscilloscope. The phone is there, the PSLab is there, and this is the Android app. Let's try auto scaling it. Let's try measuring the frequency. Yeah, yeah.
We have a few minutes left, so since this is a workshop, if you want to try this yourself, you can download the PSLab app from the Play Store and
yeah, you can try it yourself. So we have the one SSID there, and if you want, you can see this for yourself. That's the oscilloscope there.
So as you showed that, like with this approach, we can also use it with iOS, yeah, and Flutter can also provide you can also build a deb package, a Debian package with it, for example, or yeah, for Windows and so on. What are your plans in this direction?
So the nice thing about, as you mentioned about Flutter, the nice thing is that Flutter has a socket, like support for web sockets in its native libraries only, right? So in the Dart core library, it has support for sockets, which means we do not have to go down to the native frameworks using message channels for that, which means that we can implement sockets in Dart, and then we can deploy on any platform which Flutter supports, right? We can deploy on Android, we can deploy on iOS, Windows, Linux, anything. And yeah, it would work the same as it worked on an Android device, right? So yeah, that's the plan forward. Yeah, developing a Flutter app and like a uniform, single code base for all the platforms which we plan to support. And yeah, for that we have the next session as well, setting up Flutter. And yeah, so this was the process to use the Android app with Wi-Fi. Let's move forward.
I think we're at the end of like our sort of demonstration here. So
Yeah, exactly.
In the last few minutes here, feel free to.
Yeah, so if you want, you can download the latest version, which is in production from the Play Store, and you can come here and you can try this process yourself. Anyone who would like to come here, I'll be glad to assist.